This is Foundational Mathematics for Secondary School Intermediate Level. This course is facilitated by Limitless Learning TT, where it's all about learning on the go. Log into your website from any place at any time and view past videos, practice problems, and solutions for your course. For more information on the services we offer, please visit our website at www.limitlesslearningteach.com. And if you have any additional questions or concerns, please feel free to send us an email at info@limitlesslearningtt.com. In today's lesson, we're going to be doing an introduction to functions, basically explaining what is a function, discussing domain and range, and of course, the formal definition of a function, and then examples. So functions, what is a function? The best way to think of a function is there's some sort of input, there's something that happens, and then there's an output. So sometimes the easiest example you can think of is you have oranges, right? You put them in a juicer, and then what comes out is juice, as in orange juice, right? So your oranges are your input. What you get at the end, orange juice, is your output. And what allows you to go from your input to your output is known as your function. So a function is something that takes your input and produces some sort of output. Now, what is the formal definition for a function? A function relates each element of the domain to exactly one element of the range. Now, this is a formal definition of a function. However, we have mentioned certain terms in there that we don't know as yet. Elements, domain, range, what exactly are we talking about? So I'm going to keep my formal definition. I'm going to move it to the top here so that we're going to remember it. We're going to come back to it in a while, but I am going to introduce some terms that are within our formal definition and just kind of break it down so you get an idea. So we already know that you have some sort of input, then there's a function, and that creates an output. So I'm going to keep this example with the oranges and the juicer and the orange juice up, and instead I will say, suppose I had these numbers 1, 2, 3, and 4. These are my inputs. Let me redo it. Right, so I have these numbers, these 4 numbers. These are my inputs. I have these numbers here. These are my outputs. And there is some function that takes 1 to 5, 2 to 6, 3 to 7, and 4 to 8. Now, the numbers that I have as my input, these are elements. So 1, 2, 3, and 4 are elements. And this entire set or circle that includes those 4 elements are known as my domain. So when I talked about input is the same thing as your domain. So input, which was your oranges, is the same thing as your domain. Now on this side, my output is going to be the same thing as my range. So I'm now introducing two terms. When we spoke about inputs, what you put into the function, that's going to be known as your domain. So those sets of elements make up your domain. Those elements, 5, 6, 7, and 8 are also elements in that set, which was your output, is known as your range. So input is domain, output is range, function remains the same. Now, what takes us from the number 1 to the number 5? Well, if we add 4 to 1, we end up with 5. If we also add 4 to 2, we end up with 6. If we add 4 to 3, we end up with 7. And if we add 4 to 4, we end up with 8. So our function, in this case, is going to be adding 4. So our function is going to be adding, if you add 4. And you always perform your function on your domain. So your function goes with the domain and then gives you an output. So your domain element, one of the elements is 1, you perform the function on that 1. So you add 4 to that 1 to give you an output. You add 4 to the number 2 or the element 2 to get something in your output. You add 4 to the number 3 to get something in your output or your range. Okay, so I've introduced elements. Elements are the things that are in your domain and your range. Sometimes it can be numbers. For the sake of math, it will be numbers. It can be letters, basically anything. And your domain is regarded as your input, and then your range is regarded as your output. Now, this that I've just done here, showing a domain, a range, and then a line that represents a function with an arrow going with the arrow pointing in the direction towards the range, saying that you're moving from the domain to the range. This drawing is known as a mapping. And this specific mapping is called a one-to-one mapping because each element is mapped to one element in your range. So I have one element in my domain mapped to exactly one element in my range. So it looks like every one element goes to another one, right? A distinct one. So this is known as a one-to-one mapping. One-to-one mapping. Now, there are several ways or several different mappings that there are. There is one-to-one, there is many-to-one, there is one-to-many, and there's many-to-many. So let's look at what those look like. So before we were able to show 1 to 1, 1, 2, 4, and let's say this is 8, 7, 3. This is a 1 to 1 mapping. 1 to 1. Now we can have an instance where 1 minus 3, 8, 4, 2. In this instance, right, all of my elements in my domain are mapped to one element in my range, right? So in my domain, I have 1, -3, and 8, and they're all mapped to the same number, which is 4. That's in my range. And since I have many elements going to one element, this kind of mapping is known as a many-to-one. Another example of a many-to-one can look something like this. Let's say you have the numbers 1 and 2, 3 and 4, 5 and 6. I can have 1 and 2 going to 5, and I can have 3 and 4 going to 6. So I have many elements going to 1, right? That's known as a many to 1. Then there is something known as a one to many, and I'm pretty sure you guessed this. You have one element going to many elements in your range. So alright, so let's say 1, 2, 3, you have 4, 5, 7, and let's say the number 1 is going to 4 and 5, and the number 2 is going to 5 and 7. Right? You have one element that goes to many elements, or goes to more than one element in your range. This is known as a one to many. And then the last one is known as a many to many. Let's say you have, it doesn't matter, 1, 2, 3, 5, 6, 7, 8. So a many to many is like a combo or combination of many to one and one to many. So you can have something looking like this. 1 going to many. Also, you can have many going to 1. Right, so this is an example of many to many. Right, so there are 4 types of mapping: a one-to-one, a many-to-one, a one-to-many, and a many-to-many. Now, the important ones that we want to note will be these 2 on the top here: many-to-one and one-to-many. These 2 examples or 2 types of mappings are functions. So functions can only be a one-to-one mapping or a many-to-one mapping. If you have a one-to-many, it's not a function. If you have a many-to-many, it's not a function. And let's look at what the definition of a function says. A function says that it relates each element of the domain to exactly one element of the range. So in my first case, one-to-one, that's pretty clear, right? Each element, 1, is related to 8, one exact element. 2 is related to one exact element, 7. 4 is related to exactly one element, 3. When you're looking at many to one, right, we have the elements of the domain relating to exactly one element of the range. So 1 goes to 4, only 4. 3 goes to 4. 8 goes to 4. It only goes to one element. So when you're looking at what represents a function, you're really looking at that line that represents a function, and you have to make sure that your lines only point to one element in your range. If you look at many to one, you will see you have one element going to 2 things in your range. You only want to go to one element in the range. So therefore, this cannot be a function. And then, of course, many to many, even though you have 3 of them, 1, 2, and 3 going to 7, because of the fact that you have 1, the number 1, going to 5 and 6 and 7, you have a one to many. So this is not a function either, because again, you're looking to make sure that each element goes to exactly one of the range. It cannot go to more than one element that's in your range. So when we're talking about functions, the only mappings that we care about are a one-to-one and a many-to-one. Anything that ends with to one. So one-to-one, many-to-one, those are the only examples of a function. So thus far, what we know about functions, we know that we have a domain. We know that we have a range. And we know that our function takes elements from our domain to our range. Now, a function, you can think of a function as essentially an equation. I'm going to put blue in the middle to represent a function. Right, so function is taking my elements of my domain to my range. Now, within my domain and my range, I usually have numbers, and those are my elements. And the function you can think of as it's essentially an equation. So if a function is an equation, right? Because in the beginning, when we had, for example, 1, 2, 3, and we had 5, 6, 7, what we were doing is adding 4. So our function was basically my domain plus 4. Okay, so you can think of a function as essentially an equation. So if a function is essentially an equation and you can represent an equation graphically, that means that you can represent functions on a graph, right? Makes sense. So if we have an equation, we know we have linear equations, we have quadratic equations. Those are things that we would have covered in the beginner level of this course. So you know you have linear equations and you have quadratic equations, and those can be represented graphically, which means that a function can also be represented graphically. Now remember, we said a function can only be one-to-one mapping or many-to-one mapping. What if we have a graph? How do we know if our graph is a function or if it isn't a function? So for example, if I draw a graph, right, this is my x-axis, this is my y-axis, and my graph looks like this. How do I know if this line that I drew is a function or not? Now, when you have a graph and you're trying to indicate if it's a function or not, you're going to do something that is known as the vertical line test. It means that if I drop a vertical line anywhere along my graph or my line or my curve, my vertical line should only cut that equation once. So right now I've drawn a straight line. It's some random line with an associated equation, and I want to know if this line is a function or not. Well, according to my vertical line test, if I put a vertical line anywhere along this red line, so vertical line, vertical line, vertical line, vertical line, vertical line, my vertical line must only cross my red line once, and everywhere here that I've dropped a vertical line, it has only crossed my red line once, so that means that this red line is a function. Now, I can do the same thing with a curve. So let's say I had some curve that looks like a quadratic curve. This is my quadratic curve. Is a quadratic equation a function or not? Well, I'm going to do the same thing, my vertical line test. I'm going to draw vertical lines all over this curve that's represented by this red line, and my vertical line should only cross my red line once. So anywhere I draw a vertical line, it's only going to cross my curve once, so that means that this quadratic equation is also a function. So basically, if you want to find out if something is a function and you don't have mapping. You don't have the elements of the domain and the elements of the range to find out if it's a one-to-one mapping or a many-to-one mapping, and instead you have a graph. All you're going to do is do a vertical line test. You're going to draw vertical lines everywhere, and once it only crosses your curve or your straight line once, it means that it has to be a function. What if instead we had this curve that looks like this? Sorry. Right? If I do my vertical line test and I draw a vertical line here, it crosses at 2 points, here and here. If I draw another vertical line here, for example, it crosses at 2 points, here and here. So this means that once I put a vertical line and it crosses more than once, it means that this is not a function. So this graph that I've drawn here is not a function because it doesn't meet my vertical line test, again, which says that if I drop a vertical line anywhere on my curve, it must only intersect that curve once. So you can tell if something is a function, one, if you have a mapping that is with your domain and range, and you're looking to see if it's a many-to-one or a one-to-one mapping. And then you can tell if you're given a graph using your vertical line test, which says that you have to cut your curve only once if you draw a vertical line anywhere along your curve or your line. So thus far, we've been conceptually thinking about a function. We've used the idea of inputs and outputs, oranges and getting orange juice, and that going through some sort of function. We've mentioned our domain range. We know that a function looks like an equation, but we haven't actually seen it, an example, or to see what it is we're talking about. Now, since we said a function is an equation, thus far you would have done two types of equation: a linear equation, which is of the form y is equal to mx plus c, and then you would have also done quadratic equations, which look like y is equal to ax squared plus bx plus c. So basically, linear equations mean that you have x's, but x is only to the power of 1. And then quadratic equations mean that the highest power of your x's has to be 2. It can't go higher than 2. The power of 2. So you would have seen these two examples of equations. So how does a function, if a function is an equation, how do you represent a function? Now, function has its own specific notation, and it's known as f for function of x. So f of x represents our function, which is an equation. So when we're talking about functions, instead of having y in our equations, it's going to be f of x. So instead of y, it will be f of x, and instead of y here, it will be f of x. F of x just indicates that the equation that we're dealing with is a function, which means that it is a one-to-one mapping or it's a many-to-one mapping. So whenever you see the notation f of x, it means that we're specifically speaking about a function, and if we're specifically speaking about a function, it means that it can only be a one-to-one relation or a many-to-one relation. So now let's look at an example of a function and how we can work with these examples. So let's suppose I say I have a function, and my function is such that f of x is equal to x plus 4. Okay, so this is my function. the numbers that I input into my function are going to be known as my domain. So essentially, my x values are my domain because those are numbers that I can input in order to get another number. So my x values are going to be known as my domain. And then the values that I'm going to get in return are gonna be my range, and we'll talk about those values in a second. So my x values means I can pick any number for x. So let's say I wanted to do x is equal to 1. I want to find what is going to be the value when x is equal to 1. So all I do is I go to my function, and everywhere I see x, I'm going to replace with 1. So f of 1 is equal to 1 plus 4, and 1 plus 4 is 5. So the corresponding value, which is my f of x value, is going to be 5. So when x is equal to 1, I get 5. Now, you would have seen I put f and in brackets 1. This is f of 1, and that simply means the value of f of x when x is equal to 1. So f of 1 means, the value of f of x when x is equal to 1. That's exactly what we did. We replaced x with 1, and we found out what the value would be. The value in this case is 5. So now we can essentially find corresponding f of x values for our x values. So let's look at some more examples. So I'm still using the fact that my function is f of x is equal to x plus 4, and in this case I want to find f of 2. F of 2 means that I want to find my value of f of x when x is equal to 2. So all I'm going to do is replace my original function. Everywhere I see an x, I'm going to replace with 2. So that's f of 2 is equal to 2 plus 4, and 2 plus 4 is 6. I can also find f of negative 15. It means that everywhere that I see x in my f of x equation, I'm going to replace with negative 15. So f of negative 15 is going to be negative 15 plus 4, and that's equal to negative 11. Okay, so let's look at another example of a function. Suppose I had a function that is f of x is equal to x squared plus 4x minus 7. And I want to find, I have to find the following. I need to find f of 0 and find f of negative 1. So I need to find f of 0. What I want to find when I say f of 0 is I want to find the value of f of x when x is 0. So first one, f of 0 means that in my original function, everywhere that I see x, I'm going to replace with 0. So I have f of 0 is equal to 0 squared plus 4 times 0 minus 7. 0 squared is 0. 4 times 0 is 0 minus 7. So 0 plus 0 is 0 minus 7 is minus 7. So f of 0 is the same thing as negative 7. Our next one is to find f of negative 1. So I'm going to replace x in my original function with negative 1. So f of negative 1 is going to be equal to negative 1 squared plus 4 times negative 1 minus 7. Negative 1 squared, that's negative 1, multiplied by negative 1 is 1. 4 times negative 1 becomes a negative number, that's negative 4. And then minus 7. So what I have is 1 minus 4 minus 7, which is going to be negative 10. So f of 1 is equal to negative 10. So I found my answers. F of 0 equals negative 7, and f of negative 1 is equal to negative 10. Simple enough. Let's look at another example. I have another function, f of x. This is equal to x minus 3 divided by 2x minus 1. And I need to find f of 1 and f of 0. That's my question. So the first thing I want to find is f of 1, which basically is I want to find the f of x value when x is equal to 1. So everywhere that I see x in my function, I'm going to replace with the number 1. F of 1 is equal to 1 minus 3 over 2 times 1 minus 1. 1 minus 3 is negative 2. 2 times 1 is 2 minus 1. So I have negative 2 over 2 minus 1 is 1. And anything over 1 is itself. So my answer is negative 2. So f of 1 is equal to negative 2. My next question is I want to find f of 0. Basically, again, I want to find the f of x value when x is equal to 0. So anywhere that I see 0, everywhere that I see x, I'm going to replace with 0. So f of 0 is going to be 0 minus 3 over 2 times 0 minus 1. 0 minus 3 is negative 3. Divided by 2 times 0 is 0 minus 1. So I have negative 3 over 0 minus 1 is negative 1. And two negative numbers divided by each other becomes a positive number. And 3 divided by 1 is 3. So my answer is 3. So f of 1 equals negative 2. And f of 0 is equal to 3. So we can substitute our values of x and then find the corresponding f of x values. Now we can also do the reverse. We can have a value of f of x and find the corresponding value of x. So it's as though we have we know what the f of x value is. It's equal to, let's say, 13. And we want to find out what is the corresponding x value that gave us 13. So let's look at an example of that. So we have our function. Let's start off with something significantly easy. F of x is equal to x plus 3. And we want to find the value of x for which f of x is equal to 10. So I know that f of x is equal to 10. So all I'm going to do in my original equation is I am going to replace f of x with 10. So now I have 10 is equal to x plus 3. All I did was replace f of x with 10 because they told me f of x is equal to 10 and I want to find the corresponding value of x. So 10 is equal to x plus 3. I'm going to take away 3 from both sides. 10 minus 3 is 7. X plus 3 minus 3 will give me x plus 0. And anything plus 0 is just itself. So my corresponding value of x is 7. So when f of x is 10, x is equal to 7. And it makes sense because if I were to substitute 7 into f of x, so f of x is equal to x plus 3. If I were to substitute 7 for x, I should get 10. So f of 7 is going to be 7 plus 3, which is 10. So my answer is correct. So in this case, all you do is you replace f of x with that specific value, and then you find your corresponding value of x. Same function, let's say f of x is equal to negative 14. So I'm going to replace f of x with negative 14 and continue my function x plus 3. And now I'm going to solve for x. I'm going to take away 3 on both sides. Negative 14 minus 3 becomes negative 17. X plus 3 minus 3 becomes x plus 0, and anything plus 0 is just itself. So the corresponding value is x is equal to negative 17. So when x is equal to negative 17, I get f of x to be equal to negative 14. Okay, let's look at another example. I'm given the function f of x is equal to x squared minus 3x plus 2. And I want to find the value of x for which f of x is equal to 0. So all I'm going to do is replace f of x with 0. So I get that 0 is equal to x squared minus 3x plus 2. So essentially, I have a quadratic equation that I need to solve, right? It's of the form ax squared minus b plus bx plus c is equal to 0. Right, now you can solve this quadratic equations two ways. You can use the quadratic formula, and again we would have discussed this in the previous course, which is the beginner course for foundational math for secondary school. You can use the quadratic formula, or you can factorize. Either one is going to give you the same answer. I'll do both just as a refresher. So I have x squared minus 3x plus 2. It is of the form ax squared plus bx plus c is equal to 0. Right? Where a is 1. In my case, right? Because this is x squared means 1 times x squared. A is 1, b is negative 3, and c is 2, right? If I use those values, I'm going to get this equation on the top here. So I know a is equal to 1, b is equal to negative 3, and c is equal to 2. And I remember that my quadratic formula says x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. And all I'm doing is substituting my values for a, b, and c into that formula. So I get that x is equal to negative b, which is negative 3, plus or minus the square root of negative 3 squared minus 4 times a, which is 1, times c, which is 2, all over 2 times a is 1. A is 1. So I get x is equal to 3 because negative times a negative sign, when I have two negative signs, it results in a positive sign. So I get 3 plus or minus negative 3 squared is going to be 9. 4 times 1 is 4 times 2 is 8, so 9 minus 8. All over 2 times 1 is 2. I can simplify within here further. 9 minus 8 is the same thing as 1. Right, so I now have 3 plus or minus the square root of 1 over 2. And the square root of 1 is 1. So now I have 3 plus or minus 1 over 2. And I can simplify my answer. So my answer is either going to be 3 plus 1 over 2 and or 3 minus 1 over 2. So 3 plus 1 is 4. 4 divided by 2 is 2. And 3 minus 1 is 2. 2 divided by 2 is 1. So my answers are going to be x is equal to 2 and x is equal to 1. So that's doing the quadratic formula to find your answer. Right, so again, function something new, but it uses the information or the topics that you would have learned before, which would have been quadratic equations. And again, that was covered in the beginner course of this, in the beginner level of this course. Okay, you could have also factorized. So quadratic formula is one way. This is just a quick refresher, because you will see quadratic equations within functions. You could have also factorized here to get x minus 1 times x minus 2 is equal to 0 if you factorized this function. And so that means x minus 1 is equal to 0. And x minus 2 is equal to 0. So if x minus 1 is equal to 0, it must mean that x is 1. And if x minus 2 is equal to 0, it must mean that x is equal to 2. So you get the same answer again. X is equal to 1 and x is equal to 2. Same answer here. So it doesn't matter whether you use the quadratic formula or whether you use factorization. Your answer is pretty much still going to be the same. Let's look at another example with functions. You are given the function f of x. F of x is equal to x plus 3 divided by x minus 2. You have to find f of 7, f of negative 16, and you also have to find the value of x when f of x is equal to 6. Okay, so let's start with the first one, and that is finding f of 7. So basically, I'm going to replace 7 anywhere that I see x in my function. So f of 7 is going to be equal to 7 plus 3 divided by 7 minus 2. 7 plus 3 is going to be 10. 7 minus 2 is going to be 5. 10 divided by 5 is 2. So f of 7 equals 2. Fantastic. Next one, or next question related to this is I need to find f of negative 16. So again, I'm going to my function, and anywhere that I see x, I'm going to replace with negative 16. So I get f of negative 16 is going to be equal to negative 16 plus 3 divided by negative 16 minus 2. Negative 16 plus 3 is going to be negative 13. And negative 16 minus 2 is going to be negative 18. And when I divide two negative numbers, I get a positive number. So this is 13 divided by 18. And I can't simplify this fraction any further. So my answer is 13 over 18. So f of negative 16 is equal to 13 over 18. Okay, and then the last part of the question, you need to find the value of x when f of x is equal to 6. So I am going to replace f of x with 6. So I get that 6 is equal to x plus 3 divided by x minus 2. So what I have to do here is solve for x. Now this one is a little bit tricky, but again, you're just going to follow the rules for solving equations. So right now, what is problematic is the fact that I have an unknown variable, or my x value, in my numerator as well as my denominator. That's on the right hand side. So I have this denominator here, x minus 2. I really want to get rid of that. Since it's in the denominator, because this is technically saying x plus 3 divided by x minus 2. If I need to get rid of this x minus 2 in the denominator, I have to do the opposite of divide, which is multiply. So I'm going to multiply both sides by x minus 2. So I get 6, which was here before, times x minus 2 is equal to x plus 3 over x minus 2 multiplied by, I'll put it as a dot, multiplied by x minus 2. Now remember, if I have something like 4 over 3 multiplied by 3, my 3's can cancel. That's why we multiplied by x minus 2, because it's going to mean that this is going to cancel with this. So I am left with 6 times x minus 2 is equal to x plus 3. Okay. So then take this off. So this cancels. And I'm left with 6 times x minus 2 is equal to x plus 3. Then the next thing I'm going to do is expand these parentheses or brackets. So I have to multiply 6 by each term. 6 times x gives me 6x. 6 times negative 2 gives me negative 12 is equal to x plus 3. Then next, I want to put all my x's on one side and all my numbers on one side. So the first thing I'm going to do is get rid of this 12 here that's on my left hand side. And I'm going to do that by adding 12 to both sides. So on my left hand side, I have 6x minus 12 plus 12. Well, minus 12 plus 12 is going to give me 0. So I have 6x on my left-hand side. And on my right hand, I have x plus 3 plus 12. Plus 3 plus 12 is 15, so that's x plus 15. Next, I want to get rid of this x that's on this side, so I'm going to take away x from both sides. So on my left-hand side, I have 6x minus x, that gives me 5x. And on my right-hand side, I have x minus x, is going to give me 0, because anything minus itself is going to give me 0. So I get 0 plus 15, which is just going to be 15. Now I have 5x is equal to 15. I want to solve for x alone. On my left-hand side, I have 5 times x. So that means that I need to divide both sides by 5. 5x divided by 5 will leave me with x alone. And 15 divided by 5 will leave me with 3. So when x is equal to 3, I get a corresponding f of x value of 6, and that's true, because if I were to substitute 3 into my original function. On the numerator, I will get 3 plus 3, which is 6. And on my denominator, I'll get 3 minus 2, which is 1. And anything divided by 1 is itself. So I'll get 6 divided by 1, which is 6. So my answer of x being equal to 3 is correct. So that brings us to the end of this lesson. Again, we would have done an introduction to functions. We would have given a conceptual idea of what is a function. Then we would have talked about the proper definition for a function. We'd have introduced our domain, our range, what are our elements. We also would have shown how what represents a function, that is a one-to-one mapping, a many-to-one mapping, and then if you have a graph, you use the vertical line test to see if it's a function or not. And then of course we would have done some examples of functions, that is finding the values of f of x when you're given a value of x, and then the reverse, which is you're given an f of x value and you solve for x. So this has been a foundational mathematics for secondary school, the intermediate level. This course is facilitated by Limitless Learning TT, where it's all about learning on the go. Log into our website from any place at any time and view past videos, practice problems, and solutions for your course. For more information on the services we offer, you can visit our website. That's www.limitlesslearningtt.com. And of course, if you have any questions or concerns, you can always send us an email at info@limitlesslearningtt.com.